In this video, we will learn about the basic proportionality theorem formed in a triangle. We will also learn about the corollary to the triangle sum theorem, which you previously learned from the first quarter. Firstly, let us try to explore the basic proportionality theorem. So we have here triangle ABC, and we drew a line which is parallel to side BC. Now let's take note of the measures of AD and DB, as well as AE and EC, and let's try to find a relationship between the ratios of these two. So firstly, we have here AD is 2.15 and DB is 3.17. If we divide that, we get 0.68. Also, we have AE, which is 2.65, and EC, which is 3.91. And if we divide them, again we get 0.68. So at first we think that 0.68 is of course equal to 0.68, and we can say that the ratios are the same. But to further prove our theorem, let us try to move the parallel line. So here we've moved it, and you have here AD is 3.08 and DB is 2.25, AE is 3.8, and EC is 2.77. But as you see, the ratios remain equal, which is 1.37. And even if we move it continuously, you would find that actually, as reflected in the measures and in the calculated ratios, they are equal. So what can we say again about the basic proportionality theorem? If in a triangle, a line is drawn parallel to the third side, then it divides the other two sides into proportional segments. So you have AD over DB is equal to AE over EC. Let us also briefly discuss a corollary to the triangle sum theorem. This corollary states that if two triangles have two pairs of congruent corresponding angles, then the third pair of corresponding angles are also congruent. Suppose we have triangle ABC here, which is similar to triangle DEF. Thus, their angles are naturally corresponding. Say two pairs of these corresponding angles are congruent. Then the remaining pair of corresponding angles will also be congruent by this corollary. Let us prove this corollary using our prior knowledge on the triangle sum theorem. First, we were given that triangle ABC is similar to triangle DEF. Therefore, they have their corresponding angles. Angle A is corresponding to angle D, angle B corresponds to angle E, and angle C corresponds to angle F. By the triangle sum theorem, we know that angle A plus angle B plus angle C is equal to 180 degrees, and angle D plus angle E plus angle F is equal to 180 degrees as well. By the transitive property of equality, since they are both equal to 180 degrees, we can equate angle A plus angle B plus angle C equals angle D plus angle E plus angle F. Since angle A is equal to angle D and angle B is equal to angle E, we can replace now with angle A plus angle B plus angle C equals angle A plus angle B plus angle F. Hence, we can conclude that angle C is equal to angle F, or in terms of angles, we can say that angle C is congruent to angle F. Now, let us try to apply the basic proportionality theorem in solving problem number 2 in your module 7.2.2. The problem reads, in triangle XYZ, PM is parallel to XY. YZ is equal to 10 and XZ is equal to 30. What are the lengths of XM and MZ? So from the basic proportionality theorem, we know that PZ over PY should be equal to MZ over MX. Since we were given that PZ is equal to 4 and YZ is equal to 10, then PY is equal to 10 minus 4, which is also equal to 6. And since xz is equal to 30, we can let mz be equal to x, and mx will now be equal to 30 minus x. By the basic proportionality theorem, again we can have the working equation 4 over 6 equals x over 30 minus x, which are the values of pz over py equals mz over mx. Solving this algebraically, we would get that x is equal to 12, and since we let mz be equal to x, mz is equal to 12. And mx now is equal to 30 minus x, which is 30 minus 12, and that is 18. So we have solved the problem. Before I end this video, I would like to acknowledge my references again. So mostly I've used GeoGebra to demonstrate the applications of the theorems and the figures. And also a problem in this video was taken from the Student Learning Guide 7.2.2, which is the basic proportionality theorem written by Mr. Harold Soriano of PSHS SMC.